Suppose we're given the following series. How would we be able to test for absolute convergence or convergence in general? This one, since everything's raised to the n, should give you an indication, probably the root test. This has a factorial indication, probably the ratio test. So let's do that. Let's take the limit as n goes to infinity of the nth absolute value of the nth root of this function, which is n squared plus 1 over 3n squared minus 1, all raised to the n. Well, we have some nice cancellation here with the nth roots, and we're just looking at the limit as n goes to infinity of now the absolute value of n squared plus 1 over 3n squared minus 1. Let's divide everything out by n squared, and we get the absolute value of 1 plus 1 over n squared over 3 minus 1 over n squared, which this part goes to 0, this part goes to 0. We're going to get 1/3, which is always less than 1. Therefore, we have absolute convergence here. Now, let's think about the ratio test for this one. Let's take the limit as n goes to infinity of the absolute value of n plus 1 factorial over 2n plus 1 and the square root of n plus 1 times the reciprocal of this, which is going to be 2 to the n square root of n over n factorial. Well, we have some nice cancellation, which the ratio test provides. This n factorial leaves only a factor of n plus 1 to remain. This value here will get rid of the n, and this will get rid of that entire factor. And let's see what this looks like now. We have the limit as n goes to infinity of n plus 1 times the square root of n all over 2 square root of n plus 1. Now here, if we divide everything by square root of n, we'll have the limit as n goes to infinity of n plus 1 over 2 square root of 1 plus 1 over n, because we pull in the n to the inside there. Now, this part here will go to 0, so we'll get a 2 at the bottom, but we'll have an infinity on top, which means this limit goes to infinity, which is clearly greater than 1. So this means that this series does not converge absolutely. It, in fact, diverges.